Okay, kids, so I'm going to go over the 5 oxidation problems that I gave you at the end of the last thing. But first, let me just go through a little bit of what's called oxidation and reduction, okay? So here's how it works. First of all, let me balance the equations here. By the way, the balancing does not affect what's called the oxidation and reduction, okay? I'm going to go 2, 4, and 3 there. Okay. Don't worry about these numbers. It's just the parts, right, to balance it out. And okay, so here's how it works. Remember, the oxidation number, you have the rules on how to assign an oxidation number. This is iron. Iron is Fe on the periodic table. All right. I know there's a 4 there, but don't worry about that. Can you see that the iron is there by itself? It's not with any other element. Okay. Since the iron is there by itself, it has an oxidation number of 0. Okay? Any atom in a pure element always has an oxidation number of 0. Okay, now let's go to here. I know there's 3 O2, but again, you don't worry about the 3. There's just O2 here. So it's Fe by itself plus O2. Now look, there's 2 oxygens there. But the only element that's there is oxygen, which is what I mean when I say it's by itself. So since there's nothing but oxygen there, it's a pure sample. The oxidation number here is 0. Okay? All right, now let's take a look at the after the reaction. Now you have Fe2O3, which is iron oxide, just the chemical formula for rust. It's one of the formulas for rust. There's actually a few. Anyway, now the iron and the oxygen are combined into one compound. Forget the 2's not, pretend the 2's not there, right? We're just looking at Fe2O3. All right, then what you're going to do is you're going to grab your colorful sheet, which I should have had out already. Okay? And we're going to look up both Fe and O. All right, well, if you look up O, which is right here, you get -2. All right, so let's put -2 above O. Now remember, there's not going to be what I call the battle of negativity here, because what you're going to find is that iron is here on your colorful sheet, and it has 2 choices, but both are positive. All right, so let's figure out which one it is. We know the O is going to be -2. You times it by 3, you get a total charge of -6. Now remember, most of the time you want to add up to 0. Well, that must mean that the irons need to total +6. All right. Well, if there's 2 irons totaling +6, it's going to make the oxidation number of each one +3. Okay, so now here's how oxidation and reduction works. Now, I'm going to give you the scientific explanation, and I'm going to give you the easy way to remember it. Okay, they say that oxidation is losing electrons, and reduction, keep this in mind, reduction is gaining electrons. All right. Yes, that's what it is from a scientific standpoint. However, let me make it a little bit easier for you, right? Electrons are negative. If you gain negativity, you become more negative, yeah? If you lose negativity, you become more positive, right? Okay, so let's talk about it this way. Here's an easier way. Instead of saying oxidation is losing and reduction is gaining and blah, 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 here's how we're going to remember it. If the charge goes up, it's oxidized. If the charge goes down, it's reduced, right? Like if my bank account gets reduced, like after a divorce or something, I don't have more money in there, all right? So reducing is lowering. All right, so let's see what happened from the iron from left to right. What I mean by going up or down is after the reaction. So when the reaction started, iron Fe was 0, had an oxidation number of 0, yes? But after the reaction's over, the iron's charge is +3. The charge of the iron has gone up. If the charge goes up, it's oxidized. So this is what I would write, okay? I would say that Fe, I'm going to use a different color because I used pink as the next thing. I'll use orange. Okay. Fe, which is iron, was oxidized. Makes sense, right? From 0 to +3. Okay? Fe was oxidized from 0 to +3. Okay? Now let's take a look at O. Oxygen was at 0 before the reaction. After the reaction, it became -2. All right? Let me just erase that, right? Okay. So the charge of the oxygen went down. They say reduction is gaining. It's so much easier to say the charge went down, so it was reduced. Okay. So oxygen went from 0 to -2. So I'm going to say that oxygen, or O, was reduced from 0 to -2. Okay? All right. So there we go. And that's how it works. All right. Now there's another term I need to teach you, though. All right. Don't get confused. The thing that's oxidized is called the reducing agent. Okay? The thing that's oxidized is called the reducing agent. Well, then the thing that is reduced is going to be called, you guessed it, the oxidizing agent. Okay? All right, that's kind of how it works. All right, so let's take a look at this equation here. This is something that we did in the beginning of the year when we were trying to predict the formula of aluminum by treating it with hydrochloric acid. Now, I diluted the hydrochloric acid down so that, it didn't erupt all over the place. Okay, we just used regular aluminum foil, treated it with HCl, hydrochloric acid, to produce aluminum chloride, which is like prescription strength antiperspirant, and hydrogen gas would go and leave. All right, well, let's see. We got aluminum here, an element all by its lonesome, no other elements with it. That's going to make, it's a good thing I trimmed my nose hair, it's going to make the oxidation number for aluminum 0, because it's by itself, it's on its own. All right, now let's check out HCl. So we'll go to our colorful sheet, right? All right, well, I got Cl -1, H is up here, +1. All right, so we got positive and negative. Positive and negative is fine. There's no battle there. +1, -1. So that's the oxidation numbers, right? +1 and -1. Now you have aluminum and chlorine together. All right. So now they're not, this isn't 0 anymore because it's with Cl. Okay, well, Cl -1, Al +3. Okay. Remember, this is in compounds. So Al, we got +3. Cl is -1. Okay, then over here we have hydrogen. Now hydrogen, H2, it's a diatomic molecule. So is oxygen. So is nitrogen. So is fluorine. So is chlorine. So is bromine. So is iodine. They don't occur as just regular elements on their own. They occur as doubled up versions of themselves, or they share electrons and they become diatomic molecules. Anyway, it's H2, but can you see the only thing that's there is H? There's no other element with the hydrogen other than H. When that's the case, the oxidation number is 0. Okay? All right. So let's see what happened. Let's start with Al. Al started as 0. After the reaction, it went up to +3. Okay, so that means the aluminum was oxidized, right? It was oxidized. You have to forgive my bad writing. It's normally not this bad. From 0 to +3. Actually, when we're in class, my handwriting is impeccable. It's actually beautiful. You know how modest I am. All right, anyway, let's look what happened with Cl, though, okay? Cl was -1 and it ended up at -1. So it didn't change. So nothing happened there. It still has the same oxidation number, but the hydrogen started as +1, and then it went down to 0. See that? So it went, +1 down to 0. If it goes down, it's reduced, right? Okay, so the hydrogen then was reduced. H was reduced from +1 to 0. What are you doing? Nothing? Is your iPad dead?
No.
Okay. All right. We'll finish the rest of your stuff soon. All right. So let's see. Then remember, if it's oxidized, it's the reducing agent. If it's reduced, it's the oxidizing agent. Okay. But now I probably would have balanced this equation with some of this. Okay. But it doesn't need to be there. I mean, you don't have to balance it. I probably would give it to you balanced already. You know what I mean? So that's probably what I would have done. So this one, I'm going to have you try on your own. So potassium in water. This is a cool reaction if I could do it for you in the classroom. You drop the potassium in water. It actually catches fire. It's pretty cool. It ignites the hydrogen gas here, the H2, right? So you got, I mean, if you want to balance it, let's see, you're going to end up having to get 4 hydrogens here. So you're going to end up with a 2 there, all right? And that's going to give you 2 H's and 2 more is 4. So 2 there will be nice. They'll give you 4 H's. There's your 2 O's. There's your 2 O's. And there's your 2 K's, okay? So if you want to try that one, and then just see what the oxidation number is of each thing and tell me if it was oxidized or reduced. Before we go, I want to give you the answers to the oxidation numbers from last week that we had put up. And I'll make sure I don't erase that one on the bottom there. Okay, so you give that one a shot and see. All right, let's see. So we had AgNO3. We had PO4 with a 3- charge, phosphate. C3H6, propene. Cr2O7 with a 2-, that's the dichromate ion. And then we had WCl6. Okay. These were the answers that you should have had. +1 and -2. That's definite. Now, you look up nitrogen, you'll see it's -3, but it can't be -3. All right, so you're going to end up with -6 here, +1. The nitrogen is actually got an oxidation number of +5. Okay? PO4, phosphate ion, -3. You look up P and O on your colorful sheet, you'll find they're both negative. However, oxygen's the more electronegative element, so it ends up winning. -2 times 4 is -8. We have a total charge of -3. The phosphorus has to be +5. And there you go, okay? Carbon and hydrogen. Close in electronegativity value, but carbon does win out over hydrogen. So hydrogen is +1, and then we'll do some simple math here to get 0, right? You're going to end up with -6, so you're going to get a -2 there as your oxidation number for the carbon. Remember, the oxidation number is the charge of just one atom. The total charge is when you have them all together. One hydrogen's +1, so 6 of them will be +6, okay? There's 3 carbons, each one's -2. Dichromate, Cr and O. O only loses to fluorine in a battle of electronegativity. It's going to be -2, which means the chromium's definitely positive and definitely one of the ones on your colorful sheet. -14 there. -2 times 7, -14. We need to add up the -2. Well, the only way I'm going to end up with -2 is if my chromium's total +12, right? 12 minus 14 will give us -2. It's going to make the chromium +6. This is what they use in the breathalyzer tests. The dichromate ion can based on the alcohol will affect it, and it will change its charge and change the color of the chromium, and then the police officers can tell how much alcohol was in somebody's system. Okay, W and Cl. If you look at tungsten on your colorful sheet, I mean, there are a slew of charges there, all right? But they're all positive. Chlorine is -1, okay? Against most of the elements on the periodic table, with the exception, really, of fluorine and oxygen. Chlorine will pretty much win out in electronegativity value. So we're going to go -6 there, equals 0. You tungsten, you have to be a +6. Okay? All right, and then I will post the answer to this in the video. I'm also going to give you a couple more of those to try. This is the one I want you to do first, though. And then I'm going to give you, let me give you 2 that you can try, okay? How about, let's do the combustion of benzene, C6H6 plus O2 yields CO2 plus H2O. All right, I want you to give me the oxidation number of each element. Tell me what was oxidized and what was reduced. That was a bad 6, okay? And then, how about, I'll give you a nice simple one. How about H2 plus Br2 is HBr. And maybe you can balance them too. Maybe you can balance those equations and see, just to give yourselves a little more, a refresher on balancing. All right? I'll see you soon.